Students, let us solve this Irodov problem number 1.61. Two touching bars 1 and 2 are placed on an inclined plane forming an angle alpha with the horizontal. What is the situation? There is an inclined plane of angle of inclination alpha with horizontal. There are two blocks, block 1 and block 2. The masses of the bars are equal to m1 and m2. So the mass of this block is m1 and mass of this block is m2. And the coefficient of friction between the inclined plane and these bars are equal to k1 and k2 respectively. What is the question? There is a coefficient of friction between 1 and the inclined plane which is equal to k1, and there is a coefficient of friction between block 2 and the inclined plane which is equal to k2. And it question, it is given that k1 is greater than k2. What is the part is, two touching bars 1 and 2 are placed on an inclined plane forming an angle alpha. So both the blocks are placed and the coefficient of friction k1 is greater than coefficient of friction k2. So this is the situation. Now what is the question? The question is this: find the force of interaction of the bars in the process of motion. Okay, it means that both blocks are moving and we have to find the force of interaction between block 1 and block 2. So this is called normal force. So we have to calculate the normal reaction at this surface. Let me call it as N1. So we have to calculate the normal N1. And in which process both are moving. So in question it is given that both are moving. Now there is a normal reaction also at this surface. I called it N2, and there is a normal reaction at this surface. I call it N3. So first I draw the free body diagram. When these N1 act, it means that both block 1 and block 2 are in contact. So if the acceleration of this block is in downward direction and its magnitude is a, so the acceleration of block 2 is also down the plane with acceleration a. So let me draw the free body diagram of these two blocks. So mg will act in vertically downward direction, but it has a two components, one in the direction parallel to the plane and one in the direction perpendicular to the plane. The parallel component is mg sin theta and the perpendicular component is mg cos theta. There is a normal by the inclined plane which is equal to n2. There is a normal on 1 by block 2 in down the plane direction, and when this block move in down the plane direction, the friction force will act in up the plane direction, and which is equal to k1 into n2. The normal must be n2 because friction is acting on this surface, so normal must be n2. Now what is the equation for block 2? The component of mg in this direction is m2g sin theta. The component of mg in this direction is m2g cos theta. Normal on block 2 by the inclined plane is n3 in this direction. Normal on block 2 by block 1 is in this direction and its number is n1. This block is also moving down the plane, so the friction force will act in the direction up the plane and its number is k1 into n3. K1 into n3. So let me write the equation for this. Now from this equation it is clear that n2 must be equal to m1g cos theta. So the equation is m1g sin theta plus n1 minus Kn2 must be equal to m1 into A. m1 into A. Now n2 is equal to m1g cos theta. So put this number m1g sin theta plus n1 minus k m1g cos theta must be equal to m1 into A. For this block, n3 must be equal to m2g cos theta, and the equation of acceleration is m2g sin theta minus n1 plus kn3, and it should be equal to m2 into A. The acceleration of two blocks are in same direction with same magnitude. Now put this value of n3, m2g cos theta. The equation becomes m2g sin theta minus n1 plus k m2g cos theta should be equal to m2 into A. So I have two equations. One is this and second is this. And I have two unknown. One is n1 and other is A. Now in first part, what we have to calculate? We have to calculate the value of n1, not the value of A. So to solve, first it is easy that first we have to calculate the value of A, which is easy to calculate. For that we have to just add these two equations. So when we add these two equations, this is m1 plus m2 into g sin theta. In question it is given alpha, so I take it as theta. Sin theta, this plus n1 minus n1 will cancel out, and this is plus, okay, coefficients are different, so this is wrong. This is k1 and this is k2. Okay, so not plus k2 m2 g cos theta minus k1 m1 g cos theta should be equal to m1 plus m2 into A. So if we divide this m1 plus m2, this will be cancelled out, and in this part g cos theta is common, so the value of acceleration is A is equal to g sin theta and k1 is greater than k2. In question it is given that k1 is greater than k2, so this must be k1 minus k2. So minus k1 minus k2, k1 m1 minus k1 m1 minus k2 m2 divided by m1 plus m2 into g cos theta. So this is the answer for acceleration, but we have to calculate the normal reaction n1, not the acceleration. So normal reaction n1 must be equal to m1 A. Normal reaction n1. There are easy way to solve the value of n1. Let me write this equation in different form. Divide this m1 and remove m1 from this part. So A is equal to, divided by m1, So it will be equal to g sine theta plus n1 by m1 minus k1 g cos theta. Okay. Now remove the m2 from this part. So again a is equal to g sine theta minus n1 by m2, and m2 will be cancelled out. So plus k2 g cos theta. So from these two equations, both are the value of a. Left hand sides are equal, so right hand sides must be equal. It means that g sine theta, g sine theta. Okay. Now this part must be equal to this part. So n1 by m1 minus k1g cos theta should be equal to minus n1 by m2 plus k2g cos theta. So n1 by m1 plus n1 by m2 equal to k2 plus k1 into g cos theta. So from this equation I can easily calculate the value of n1. n1 must be equal to m1 m2 divided by m1 plus m2 into k1 plus k2 into g cos theta. So this is the value of normal reaction. In the part B, the minimum value of the angle alpha at which the bar starts sliding down. So we have to calculate the value of angle alpha, which I call theta, so that it starts sliding down. It means just sliding occur. It means acceleration is just above the zero. So for approximation we can put the a value of a as 0 and find the value of theta. So when acceleration is 0, this part is 0, it means g sine theta minus k1 m1 minus k2 m2 divided by m1 plus m2 into g cos theta. So this part must be equal to this part, so g will be cancel out, and sine theta by cos theta equal to tan theta. So tan theta must be equal to, now there is a minus sign which will become plus sign. So it will be equal to k1 m1 minus k2 m2 divided by m1 plus m2. So I don't know the number theta, but for understanding let me call that this theta is 25 degree. So if you make angle theta such that it is 24 degree, it means blocks will not slide. Due to friction force, block will not slide. When theta is 26 degree or above, 27, 28, 29, anything, block will slide down. Blocks will slide down and the acceleration of both blocks are same. Now one thing you must remember that this is the value of normal reaction. This is the value of normal reaction when both blocks are sliding. So in this situation, this is the normal reaction. What is the normal reaction when both blocks are not slide? That is theta is less than 25 degree. The answer will be different. But in this part, this question is not asked, so I am not going to solve. But for this part, the value of n1 should be different, not this answer.